Do you feel like stealing your neighbor's bicycle and riding 15 miles to the nearest railroad track and then placing your $400 mobile phone on the tracks while the trains are coming because you feel dumber than your smartphone when it comes to math? Hot diggity. Well, we can help you avoid breaking about 5 state and federal laws by watching this here video by Fort Bend Tutoring and Mr. Witt.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about finding and graphing holes, H-O-L-E-S, in your rational functions. That's right, rational functions. And the format for these rational functions is going to be in the form of f of x equals to p of x, which is a function, divided by q of x, which is another function, especially when the function in the denominator, that q of x there, it cannot equal to 0. Yeah, because you can't have 0 in the denominator of a fraction. It would be undefined. So let's go ahead and see some examples of how to find a hole in the middle of my graph. How can I do that? Well, how do you find holes? Well, for one, it's going to be imperative. It's going to be important. It's going to be like the first step that you should go ahead and factor everything completely. Yeah, completely factor that. Get started on that. Then, after you factor everything completely, your second step, if the numerator and the denominator have any common factors, you want to set those factors equal to 0 and solve for x. All right, because what you'll be doing in a reducible fraction, that means that once you have everything factored and you see that you have factors, especially factors that contain a variable that can be canceled out, those are the things that you're looking for. Yeah, you're looking for those factors that can be canceled out that also contain your variable. Yeah, those factors, you'll be setting those equal to 0 and solving for x. Then your third thing you want to do, because each one of these holes, ladies and gentlemen, is going to be a point. It's going to be a hidden point, especially if you're using a calculator. You won't even see these hidden points on most calculators. So it's up to you to find out where this elusive hole is hiding. And to find out the y value of that point, you want to plug your solutions for x into the simplified function to find your y value. That is the y value of the hole. You got it. It's going to be a point. You need x and the y value. All right, so next up, let's look at a problem. And in problem number 1, we have n of x equals to 7x divided by x. And the first thing you want to do is you want to factor the rational expression completely. Well, in this particular problem, it's already in its factored form here. See, this n of x equals 7x divided by x, you can't factor this. Nah, you can't factor this. But what you can do, notice, is you can cancel out those x's. Yeah. So it will be simplified to n of x equals to 7. All right, well, that means I'm going to have a hole in this expression. Why do I have a hole? Because I found a factor, this variable x here, that could be canceled out. It could be reduced. The original rational expression could be simplified by canceling out a factor that contains your variable. That's going to let you know that this graph has a hole in it. And how do you go about finding that hole? Well, first of all, I know that the factor that got canceled out is the variable x. So that means I'll be taking that variable x there and setting that equal to 0 and solving for it. Well, I just did, because x equals 0. But now that you know that x equals 0, and I told you that every hole is an actual point on the graph, you need to find out what the y value is going to be. Well, you're going to plug it into your simplified form. Well, the simplified form of your equation is n of x equals 7. So it really doesn't matter what the value of x is, whether it's 0 or anything else for that matter. Your y value is going to equal to 7. So no matter what I plug into this simplified equation, my y value will equal to 7. Well, that helps me out because that lets me know that my hole is going to be located at 0, 7. That's it. We found the hole in this graph. And mind you, notice that the format of this equation, this simplified equation, this n of x equals 7, is just going to be a horizontal line. It's going to be a horizontal line that has a hole at the point 0, 7. So let's go ahead and graph it. So here we have our original rational function here, this n of x equals 7x divided by x, and we know it can be simplified to n of x equals 7. Our hole is going to be located at 0, 7. So all I'm showing you in this video is one step of graphing rational functions, and that is finding and graphing the holes. All right, so let's graph this hole. It's at 0, 7, right? So from the origin, I'm going to be going up 7 places. So I start at the origin, I'm going up 1, 2, 3, 4, 5, 6, and 7. And I have a hole right here at 0, 7. That's it. That's my hole, and it's graphed. And done. That's problem number 1, ladies and gentlemen. Let's move on to our next problem. All right. So our next problem is problem number 2, and we have f of x equals x squared minus 25 divided by 2x minus 10. Well, the first thing you want to do here is put this rational function in its factored form. So notice that in the numerator you have a difference of squares, and in the denominator you have a GCF of 2. The greatest common factor is 2, and you could factor that out. So let's go ahead and get to factoring here. We can rewrite this rational function as f of x equals x plus 5 times x minus 5, and all of that is going to be divided by 2 times x minus 5. So notice it's the x minus 5s that can be canceled out. In other words, this is a reducible rational function here, and when you simplify it, all right, you'll just end up with x plus 5 divided by 2. So this would be the simplified form of my rational function here, all right? And I'm keeping in mind that the factor that was canceled out that contained my variable is x minus 5. That's how I'm going to end up finding the whole. So what we're going to do here in our next step, we're going to go ahead and set that factor equal to 0 and solve for x. In other words, we're finding the x value of the whole. So I'm setting x minus 5 equal to 0. I'll then solve for x by adding 5 to both sides of the equal sign. Oh yes, I will. And that gives me x equals to 5, all right? So 5 is going to be the x value of my ordered pair for my whole. Okay, in order to find out the y value, you're going to plug it in here, right there, into the simplified form of our equation here. So in order to find out what y is, this y value of my whole, you're going to go ahead and plug in 5 into the simplified form of the function. So we'll have 5 plus 5 divided by 2. Well, I know that 5 plus 5 is 10, right? Okay, and what's 10 divided by 2? Exactly, it's 5. So it turns out that our ordered pair for our whole is going to be at 5, 5. All right? And hold on here. I'm just now thinking about this. I forgot to put a red box around my previous answer. What is wrong with me? Let's go ahead and put a red box around this. There you go. We red box it at FBT. That's right. So red boxing it. Done. That's my whole. Let's go ahead and graph it now. Moving on to graph. We have our original function, f of x equals x squared minus 25 divided by 2x minus 10, and we know the whole is going to be at 5, 5. All right, so what are we here to do today? We're here to find and graph the whole that's going to be on the function. So here we have our Cartesian plane here, our rectangular coordinate system, and starting from the origin, I'm going to move to the right, 1, 2, 3, 4, 5, and then go up 5, 1, 2, 3, 4, 5, and I have a whole right there at 5, 5. That's my whole. Yeah, that's it. Just graphed it. It's just going to be an empty circle at that point. That's where my whole is. You got it. Oh, and speaking of graphing rational functions, ladies and gentlemen, you want to find out where your whole is before you identify any vertical asymptotes. The reason for this is because for every whole you have, you're canceling out a factor that contains the variable x, right? Well, you're not going to have a whole that's also a vertical asymptote. So find the wholes first, and then those wholes will be excluded from any vertical asymptotes that you may have. All right? So just keep that in mind. So if you have a whole, it's just a whole, and that's it. Not a whole and a vertical asymptote. Just saying. Okay, we're going to move on to our next problem. All right, continuing on. We have problem number 3. Problem number 3. We have f of x equals 2x divided by x squared plus x. In its factored form, and we're going to factor this, we're going to rewrite it as f of x equals 2x divided by, and then I have a GCF of x in the denominator, factor that out. We'll have x times x plus 1. All right, you like that? Notice that we can cancel out the x's. Yeah, go ahead and cancel out those x's there. They're canceled out now. This will simplify to give us a result of 2 divided by x plus 1. All right, so this is the simplified form of our rational function. Yep, that right there. But keep in mind, we were able to cancel out the factor x. that canceled out factor, you're going to set that equal to 0. Oh, okay, it's set equal to 0. And then you're going to solve for it. Okay, it's solved for it. So in order to find out the y value of your whole, go ahead and plug in 0 into the simplified form of the function. So you'll end up with 2 divided by 0 plus 1. All right, and that gives me 2 divided by 1 here. And we know that 2 divided by 1 is 2, right? Okay, so we solved for x. We found out it was 0. We plugged that value of 0 into the simplified form of our rational function. We calculated that. We evaluated that and ended up with 2 as a result. And so our whole will be located at 0, 2. This is the point of our whole. Yeah, red box it. Red boxing it. Just like that, ladies and gentlemen. We just located the whole of this function. And so now we'll graph it. All right. So graphing the whole of f of x equals 2x divided by x squared plus x, we'll have a whole that's located at 0, 2. Okay, so let's go ahead and graph that, okay, on our Cartesian plane. So graphing our whole, we'll start at the origin, we'll go up 2, and we'll put a, there you go. You got an empty circle, you got an open circle there at 0, 2 on your graph. That's right. Your graph will exclude that point. There'll be a hole there. A hole. All right, and that concludes that problem. We'll be moving on to the next one now. Come along. There we have it. Problem number 4, we have f of x equals x plus 2 divided by x squared minus x minus 6. You will factor this, all right? And notice that in the denominator you have a quadratic trinomial. You can factor that. You would be looking for 2 factors of 6 that'll subtract to give you 1. So I'm thinking 3 and 2 will get us there. And if you need help factoring a quadratic trinomial, check out this link right here. There you go. I'm here to help. FBT in the house. So factoring this, f of x can be factored to become x plus 2 divided by the quantity of x minus 3 times x plus 2. There you go. That's the factorization of our rational function here, f of x. Notice that our x plus 2's, they can cancel. Yeah, so canceling those out, we now have a simplified version of our original function, that is 1 divided by x minus 3. So this is the simplified version of our original function, f of x. All right, we did cancel out that factor of x plus 2, right? So that means as far as our whole is concerned, you want to set x plus 2 equal to 0 and solve for it. Okay, so solving for x, we end up with x equals to negative 2. This is going to be the x value of your whole. In order to find out the y value of your whole, you'll go ahead and solve for y by plugging in negative 2 into our simplified function. So we'll have 1 divided by negative 2 minus 3 here, and that simplifies to give us negative 1/5. So the y value of the whole we just found is negative 1/5, and our whole will be located at negative 2, negative 1/5, and this, ladies and gentlemen, is where the whole is located. So we're going to red box it. That's right, gift wrapping the answer in a box. A red box. So let's go ahead and graph this. All right, so here I'm showing that we had our original function, f of x equals to x plus 2 divided by x squared minus x minus 6, and our whole that we found is located at negative 2, negative 1/5. All right, and we're going to go ahead and find that on the Cartesian plane and graph it. All right, so starting out at the origin, I would move 2 places to the left and go down just a tad here, and you'll have an open circle right there. You'll have an open circle at negative 2 and negative 1/5, which is going to be just under your x-axis right there. And that's where the whole will be. All right, that's the graph of that problem, ladies and gentlemen. That was problem number 4. We're now moving on to problem number 5. All right, moving on so that we can do cinco. So in problem number 5, I have g of x equals 2x squared minus 8 divided by x plus 2. And we want to factor this immediately. Go ahead and factor that. So our factorization of g of x will be 2 times x squared minus 4 divided by x plus 2. But we're not done here. No, we're not done at all, because this, inside the parentheses there, that's the difference of 2 squares. if you need any help factoring a difference of two squares, check out this link right here about factoring difference of two squares. Okay, there it is. And go ahead and like it while you're at it. In fact, like this video. And thanks for watching. All right, so continuing to factor this will become 2 times x plus 2 times x minus 2 all over x plus 2. All right, and notice that we have a common factor in the numerator and the denominator, and we're going to cancel that out. So we'll end up with a simplified version of this, which will be 2 times the quantity of x minus 2, or 2x minus 4 if you prefer. And that is going to be the simplified form of our original rational function. All right, so recall, we canceled out x plus 2, didn't we? So we can go ahead and set this factor equal to 0 and solve for it. So subtracting 2 to both sides, you'll end up with x equals to negative 2. And in order to find out the y value of your whole, go ahead and plug this negative 2 into the simplified form of your function, that 2 times the quantity of x minus 2 there. So y equals 2 times negative 2 minus 2, and this gives us 2 times negative 4, and 2 times negative 4 gives us a y value that equals negative 8. So now that we have that, our ordered pair for our whole is going to be at negative 2, negative 8, and done. Red boxing it. That's right, put a red box around your answer. All right, there we have it, ladies and gentlemen, the whole for problem number 5, and now we're going to graph it. All right, so here we have g of x equals 2x squared minus 8 divided by x plus 2, and we found out that we have a whole at negative 2, negative 8. All right, so that means I'll be plotting this on the Cartesian plane here. So starting out at the origin, we're going to move 2 places to the left, and then we're going to go down 8 places. 1, 2, 3, 4, 5, 6, 7, and 8, and I have a hole right there. That's where the hole is. There you go. That was problem number 5, ladies and gentlemen. All right, so now we're moving on to problem number 6. In problem number 6, ladies and gentlemen, we have h of x equals x squared plus x minus 2 divided by 2x squared minus 8x plus 6. And we need to factor this rational function completely in order to identify any holes that we may have. So, our factored form of this original problem? Yeah, we'll be factoring this quadratic trinomial in the numerator into x plus 2 times x minus 1, and in the denominator we have a GCF, the greatest common factor is 2. So you can factor that out first. So factoring out 2, you'll have x squared minus 4x plus 3 in the denominator there, and we must factor completely. So that means that even this trinomial in the denominator, it needs to be factored. So factor completely. So I'll be bringing over our numerator, which is x plus 2 times x minus 1, and in the denominator we already factored out that GCF of 2, but the factorization for our x squared minus 4x plus 3, that's going to be x minus 3 times x minus 1, and done. Son, I had to, I'm sorry. So notice we can cancel out these x minus 1s here. All right, so our x minus 1s can and will be canceled out, and that'll leave us with a simplified function, which is x plus 2 divided by 2 times the quantity of x minus 3. So keeping in mind that factor that was canceled was x minus 1, we'll set x minus 1 equal to 0 and solve for x. All right, to find out that x equals 1. All right, that's going to be the x value of the ordered pair for our whole of this rational function. So we'll be plugging in 1 into the simplified form of our function here, and that will give us our value of y. Okay, so plug in 1 for x, right? So you'll have 1 plus 2 divided by 2 times the quantity of 1 minus 3, and that gives me 3 divided by 2 times negative 2. So we end up with a y value that is negative 3/4. Okay, so the ordered pair for our whole is going to be 1, negative 3/4, and you guessed it, here comes a red box. Red boxing it. All right, so let's go ahead and graph it. We have our original function here, which is h of x equals x squared plus x minus 2 divided by 2x squared minus 8x plus 6, and we found out that our whole is located at 1, negative 3/4, and we're going to graph it. on the rectangular coordinate system. So starting from the origin, we're going to go to the right one and almost a full unit down to give us a hole at 1 -3/4. All right, that's your hole for problem number 6, ladies and gentlemen, and that concludes this video on how to find and graph holes in rational functions. And as always, please like, comment, and subscribe, ladies and gentlemen. And if you're able, please donate, as that helps us bring you more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring. Peace.
Thanks for watching. We feel great knowing that you got some help and you're safe and sound. Now, if you'd be so kind as to like this video, subscribe to our YouTube channel, Fort Bend Tutoring, and like us on Facebook. We'd be much obliged.